Good morning, ladies and gentlemen. Good afternoon, ladies and gentlemen. Good evening, ladies and gentlemen, boys and girls, friends and neighbors. All I can tell you about this topic is it is extremely elusive for elementary mathematics students as you are. Extremely important in pre-calculus, extremely important in calculus, and extremely important in applications, scientific applications of mathematics. They're using it every day in this coronavirus epidemic, and that is logarithms. So what we're doing is the definition of log base A of B is equal to K. This is called a logarithm. And it's just a way, what is a logarithm? It's a way to write an exponential equation. So let's break this down. The first thing we need to do is, how do I read this? What's the appropriate way to read this? Let's have a little grammar lesson, a little reading lesson. Well, you read this statement right here. Log base A of B is K. So the log base A of B is K. What does that mean? What does it mean? What does it mean? Well, if I can get my pen working. What does it mean? This is what it means. It's the same as log base A of B is K is the same as A raised to the K powers B. So it is a logarithm is a way to write an exponential equation. Very important component of mathematics, logarithms. Elusive nonetheless. So this is my definition. Log base A of B is equal to K. Let me do this real quick. Is equal to K. If and only if A to the K is B. A to the K is B. And what do I have here? I have a logarithm expression that is equal to an exponential expression. I have a logarithm equation, that is equal to an exponential equation. Extremely, extremely important. So you're going to have to write this guy down here. This is the definition you want. If you want to color coordinate it, you can. The base is right here. It goes to the bottom below the logarithm. That's the base. And that's a good way to understand that's the base of your exponential as well. This is your base of your exponential, A. So that's the base of the logarithm. What does the logarithm pops out is the exponent. So that's the exponent. This K is the exponent. A to the K is B. And this is what the exponential, B is what the exponential equation equals. So you're going to have to write that down, and we're going to use this a lot. And you're just going to have to, even if you don't understand it, you're just going to have to learn how to use it. Okay? So here's my first example. And the first thing we're going to start off with is we're just going to start off with rewriting logarithms in terms of exponential equations, just so we can get a feel of what it means. So if I have log base 2 of 8 is equal to 3, what does that mean? Well, that means 2 to the 3 is 8. 2 cubed is 8. 2 cubed, and that's true. 2 cubed does equal 8. So the log base 2 of 8, what does that equal? That is equal to 3. Why? Because 2 cubed is equal to 8. Example number 2. And I definitely would, these notes are going to be an assignment. So you want to take good, clear, crisp notes, and you're going to post these notes in your assignment. Well, I could do the other way. Note that these arrows go both ways. So it's going to go this way and this way. This is an if and only if statement. So they go both ways. So if I can start out over here with the exponent, 5 squared is 25, 5 is the base, I can write that as a logarithm. What logarithm? Well, it's going to be log base 5 is equal to 2. Log base 5 of 25 is equal to 2. Why is this true? Because 5 squared is 25. So I can take this exponential equation and write it as a logarithmic equation. Logarithmic into the exponential, the exponential into the logarithm. They go both ways. Okay, let's go to, I think that was example 2, but I think I forgot to label that. All right, so now here we go. We're going to do this box thing instead of a variable. We could do a variable if we want, but we're just going to do box. So what I want to know is what goes in the box. Log base 3 of what is equal to 4? Oh, I don't know. I don't know. Well, here's how you're going to evaluate that. You're going to use the definition. You're going to say, oh, yeah, this is the base. This is the exponent. So 3 to the 4th is, you got it, 81. So log base 3 of 81 is equal to 4. Why? Because 3 to the 4th is 81. Okay. Next example here. I have this guy right here. Oh, I got fraction. Log base 6 of 1 over 36 is what? Well, how do I evaluate that? Well, I'm going to evaluate it because I'm going to look at it as an exponential equation. And what does that mean by definition? It means 6 to the box is equal to 1 over 36. Oh, well, now I'm back to a problem on yesterday's video. And what is 36? Well, 36 is 1 over 6 squared, which is equal to 6 to the negative 2. Hey, what's box? Box, then, is equal to negative 2. So log base 6 of 1 over 36 is equal to negative 2. Because 6 to the negative 2 is 1 over 36. Ooh, well, right now you're probably feeling this way. Hopefully you'll be a little bit happier about this. So you're looking like you could have a little dress on here. Okay, you did, then you're going to need long hair. All right, let's go to him. But you are going to say, I don't know what's going on. All right, let's do another example here. Log base 10 of 1,000 is equal to box. What does that mean? By my definition of a logarithm, that means 10 to the box is 1,000. Hey, 10 to what power is 1,000? Well, we know 1,000 is 10 cubed. So what's box? Box is 3. Okay, 10 cubed is 1,000. 10 cubed is 1,000. Okay, you will get the hang of it. You will get the hang of it. All right, here we go. Next example. Ooh, I have a little fraction here. I have log base 10 of 1/10 is equal to box by the definition of a logarithm. What does that mean? That means 10 to the box is 1/10. Well, we know what 1/10 is. 1/10 is 10 to the negative 1. 10 to the box. Well, what's box? Therefore, box is equal to negative 1. And therefore, log base 10 of 1/10 is equal to negative 1. All All righty. Well, I want to tell you something. I'm going to show you something here. Might take a while for it to load, but we have some time. I want to show you something. With the graphing calculator, or any calculator, you have this particular function on your calculator on your phone as well. I'm going to show you something here. If I go to my home screen, whoopsie, I don't know what happened. If I go to my home screen, okay, clear this, and I look over here, you can see this. Do you see this button here, log button? I'm going to push that button, log of 1/10, 1 divided by 10. Bam, is -1. Oh, what's log of 1,000? Bam. Whoop. That's going to be 3. What I'm trying to point out here is this log, there's not a base attached to this. There's not a base attached to this because this is what we call the common logarithm. It's the logarithm of base 10. So when you have a log of base 10, you need not write the base because it's so common and natural and nature. So if the base is 10, you normally won't see people write the base 10. You won't see people write the base 10 because it's so common. So if I have this statement right here, log, and there is no base here, looks like there should be a base, but there is no base here, that means 10. That means that guy is 10. And you can actually evaluate log base 10 with your calculator. And down the road, next week, we will show how you can use base 10 to evaluate any logarithm. But it is extremely, extremely important that you learn and know well this definition. You need to know this definition. Okay, let's go back to where we were. And I think I have a couple more properties. So if the base is 10, you don't write the base. You're just going to write it like this. And that means we need to realize that that means log base 10. That means 10 to the k is equal to b. Alrighty? So, and you can do that with your graphing calculator. So what would this be? A couple examples here. There is no base. Oh, there is a base. You just don't see it. The base is 10. What does that mean? 10 to the box. 10 raised to the box power is 100. And we know immediately what's the box? 2, because 10 squared is 100. All right. Here's another example with no base. No base means 10. You don't see the 10. And what do you know? What's the box? Well, you know that 10 to the -3 is equal to box. Well, what is 10 to the -3? By our laws of exponents, we know 10 to the -3 is 1 over 10 cubed, which is 1 over 1,000. So that's what goes in this box, 1 over 1,000. Because 10 to the -3 is 1 over 1,000. Okay? All right, I think we're going to end this video with 2 important properties of logarithms. These are 2 very important properties, and next week we will expand our discussion of logarithms to include a few more properties, but today we're going to just talk about 2 important properties of logarithms. Property number 1. Log base b of 1 is equal to k. What does that mean? That means that b to the k is 1. Well, what would k be then? Something to the k power is 1. K has to be 0 because anything to the 0 power is 1. So our first property then, I'm going to rewrite this guy, is this dude right here. It doesn't matter what the base is. It could be base 10. It could be 2. It could be whatever. But the log base b of 1 is always equal to 0. That is always true. log base b of 1 is equal to 0. And they're going to ask you that multiple times. And why is that true? That's true because b to the 0 is equal to 1. Property number 2 is log base b of b is equal to log base b of b is 1. Why? Because b to the 1 is b power. So these are two important properties. This guy right here and this guy right here that flow directly actually from the definition. All right, so I'm going to close this video. It's going to be 15 minutes. You definitely, absolutely, positively, 100%, you will need to write these notes, and you're going to post these notes. They will be as an assignment. All right, so I will see you later.